We're back. Okay, so again, we want to find a maximum to the left of this point. It cannot be between B and dot. It could be between A and B. So we have to check the type of that, which means that we have to start at the left node of that cubic. And here the same thing. What? Insert. No, not insert. I did replace. But okay. Yeah, I don't think I can know if it is case 3, 4 or 1, 2. If the only thing I know is I only have a pointer at the star. And suppose that that cubic has this type. Then it could be, it just could be case 1, because then I would be on the A, and AB has type max. If it has type max, it cannot be case 2, because none of those match, and none of those match. However, it could be case 3, which also has a maximum for BA. So I can't distinguish between case 1 and 3 if the start 1 has a maximum. What about case 2 and 4? Could be a minimum, both. The others are all different. So if the extreme type is a minimum and the one with the star, just the local extreme, is marked with the maximum, then it can be case 1 or 3. And if it is marked with the minimum, then it can be 2 or 4. In that case, the only way to figure out which one it is by looking at the distance of the extreme to one of the endpoints. Well, I'm not sure how to convert this to a maximum, to be honest. I would ask ChatGPT to convert it if it was intelligent, but yeah, it's clearly not intelligent. However, I can probably just remember it and store it in the LocalExtreme object at the moment it's generated. I really don't want to do something vague like measuring the distance between B and the next element of the B and then see that the B is closer. There must be a way to just know that the B is the one that is closest. Which one is the closest? The first one or the second one? Sorry, the first one of the cubic spanned by BA or the second one? The cubic spanned by AB in this case. In order to remember that, we have to be in the neighborhood of where I'm marking something as a local extreme to begin with. And then we have to look for the code that determines that it is a local extreme because it is close to something. That happens before handle local extreme is even called. So let's start with that. Grab source, handle a local extreme. It's called here and there and there. That's a lot of places. 3 places. I think only one of them is relevant though. Let's have a look at this one. No, maybe not. This is the, well, this is the first cubic. If it is the first cubic, then I'm not really interested in doing what I'm doing now, because we want to look at a neighboring extreme, and if it is the very first cubic that I find, then we don't have another local extreme. So let's just ignore that one at the moment. Yeah, this is the test. I think this is the one. And the third one is here. It's pretty close. Oh, that's just getting the extra sample. It's an iterative call to handle local extreme. It's not really that we found a local extreme at that point. We just want to re-enter the function to continue it. So it's definitely the previous one. And also it's not this call that does it, but it's the first call where the state is not equal to extra sample. So it's not equal to extra sample, like here, and then already here we call a set local extreme. So it would be nice in this case to know if last extreme cubic is the B of or something else. And I think I have to pass it to this function. go back here. So what is it that is close? So the step is very small, and step is last. The different absolute value between last, whatever that is, and the current W value. So I don't have to pass it. I just know what it is. Chain last. So chain last is the B, the one that is close to the extreme. It's also a cons iterator. Okay, so since B is last, it's kind of strange to have a C, because you would get the feeling maybe that C would be added after B, but that's not the case. C is just something else. Yeah, I don't feel like renaming it. Well, I could, but I don't know. How many C's do we have? How easy can I find them? Oh, pretty easy. All capital C's are just... Yeah, shall I rename it? To what? Something before A. Not even sure that A was added before B. Well, it's not even clear if A or C is created first, for that matter. No, whatever, I'll leave it like this. So now I can distinguish between the two by comparing the start one with last. And if that is equal, then we have case 3 and 4. So how do I get the start one? Start one is the one that is being marked. So that is last extreme cubic. Hey Mitchell. Now I have to make this work for this case, but also for when it is a maximum. So if the dot is a maximum, then what changes? Well, nothing here, because I just used local extreme instead of minimum. This can be the minimum or maximum. Maybe we should rename A, B, and C. Call L last. Oh, this is also last. Last extreme cubic. B is the last node and A is the last cubic. Could call AC, but the marked one C, and the one that is close, yeah, it's sometimes they're the same thing. Yeah, never mind that. Okay, so now make this a maximum, then note that in the first two cases A is left of B and therefore contains the cubic. Therefore A is the one marked as local extreme. Let's rewrite that a little bit to mention again. That is the last extreme cubic. In the last two cases, B is left of A, and therefore B contains the cubic and is marked as local extreme. Let's say I don't have to talk about the dot here. I think I can just talk about the next extreme type. So when, you know, I analyzed it with graphics, but now I have to write code. So I'm slowly changing it to something that I can use while writing the code. So this value does change. I just have to mirror everything vertically. So all of these. Which means that this thing becomes a slash, which is uphill. Yeah. Hello, Christian. So this is downhill becomes uphill, uphill becomes downhill, and all the ASCII art has to be mirrored vertically. It's mirrored in the x-axis. I think that's it. And then we have the maximum. Oh yeah, and minimum becomes maximum, of course. So I can expand the comments to contain both. Let's say maximum / minimum. That's super unclear. Oh, wait a minute. I can't mirror this one. No, just there's no mirror. This becomes underscore what? Underscore slash mirroring this becomes that. This becomes that. This becomes upper score that. The current, I mean, I just have test programs, but the current test program is that I've been working on for a long time now is this one. So it's in submodule Cairo window / tests. And then Tesu 2. Hey, hi Jess. Long time no see. Yes, I am. Okay, let's do this brute force. Minimum becomes maximum slash minimum. Uphill becomes downhill slash uphill. Oh shit. Yeah, I'll just do it manually. There's only one. Downhill becomes uphill, downhill. Hey, Lens. Well, the thing was already between the parentheses. No, I'll just add another one. Oops. So I'm just vertically mirroring them. Oh shit. I should only mirror this. I've twice the same thing. I mirrored it both. Yep. So this is the mirror in the x-axis of that one. And this one of that one and this one of that one. That's correct. And then here, well, I might as well just look at it. Well, then I have to type these quotes. That's why I copied it. And, or so that's upper and then down, up. Whoops. I missed on here. Imagine making a mistake at the beginning. I think I fourfold copied it and then changed it. So I made a mistake in the beginning. It's now everywhere the same mistake. That's why I was very, very, very secure in the beginning. Upper score down. Oops. Yeah, finished. So now at least I have my description to the maximum as well. Now to turn it into code. So we have a starting point. Yeah, let's call it start, whatever. And that's the arrow. And it depends on if we go left or right, but we go do both. So I can make a loop maybe, or duplicate the code. Because I'm not sure if I gain a lot by making a loop for left and right. I have to even call different functions, I have the feeling, or not. Yeah, let's make a loop. Let's make a loop. Okay, so the first go left is now no longer done. We're having a for loop direction. Left. Can't just use horizontal direction left. Just how it is. Less than or equal right, because it's an int, I can just add to it. Okay, what is the start? The start is equal to start one as a combination of if it is case 1, 2 or 3, 4 and whether or not we go left or right. So maybe we should start to make a distinction between case 1, 2 and 3, 4. Which is independent of the direction that I go into. So I can do that first. So in this case 1, 2, if let's call the case 3, 4, because I don't know why, but I like to equal compare in this case. So the last two cases, these are the same. That's just B. And then start must be equal to the start one, which is the local extreme cubic, okay, this one. If it is case 1, 2 and we go left. Or if it is case 3, 4 and we go right. Therefore, something, question mark, last extreme cubic. And that is the case, like what I said, was case 3, 4. And we go right. So if it is case 3, 4 and the direction is right, then the starting position is the start one. Yep. If it is not case 3, 4, therefore it's case 1, 2, so the Boolean case 3, 4 is false, and the direction is left, so the direction is not equal to right, then we also must use the start. So false equals false gives this, and true equals gives this one. Otherwise, it depends on if we go left or right, or if it is case 1 or 2, I don't really care. Let's use the case one. So in this case we must have the one, not the start one, but the one on the left. And in the other case we must have the one on the right. So maybe should not use case but direction, because of direction. So if we go right, and this is not this one, then we must take the one on the right. And if you go left, and it is not this one, you must take the one on the left. See how I can fit that on 3 lines. So again, something standard. Well, we do left first. So previous, last extreme cubic. Otherwise, standard. Next, last extreme cubic. So this would be where direction equals left, and then it doesn't fit on the line anymore. I don't like this layout at all. But okay. Yeah, I think I have it. Start. Then, what do we have to check? I want to know if now I'm going to the next cubic, and that is quite complex actually. This was the starting point. We have a start. Is this a special case, the first case? I thought it was a special case. So for example, the case 1, we start here and a B can be one of these types, depending on maximum or minimum. And I want to immediately stop if it has the extreme that I'm looking for. Meaning a minimum in this case, because the first list here is for the maximum. If B is a maximum, then then we want to stop if this is a minimum. Oh shit, wait a minute. This only talks about going left, isn't it? Yeah. Yup, only goes to the left. and \G. What am I doing? What am I doing wrong? Yeah, what I said was wrong. It's not true that this is just for going left. It's static structure, static shape. We go both. We go left and right in the same shape. Therefore, I think we must do something like I can't call this start. I just call it node. While something if direction is left minus node, else plus node. So the while must be something like when node is not on local extreme, and it is also does not contain the opposite extreme type, and then continue. Okay, what is the opposite extreme type? That's just the opposite of next extreme type. It's probably also a different function. Should take this out of the loop, I suppose. That's what I was afraid of. Might as well just duplicate the code, and this becomes more readable as well. If I have to do this. Or could create a lambda that does the advancement. And any other test. Okay, anyway, cubic opposite extreme type. When, what, how? So this is, yeah, for example, if next extreme type is a maximum, then in this case, AB could be one of these, which contains a minimum, and a minimum, and a minimum, and a minimum. It only does not contain a minimum in that case. Definitely also have to stop in that case. Yeah, I think that I might as well stop when there is any extreme except the first step. Because, like, say, let's do the minimum again, because that's what we're used to. Suppose this is a minimum and we go to some side, left or right, and AB looks like this. Or well, yeah, then I don't care that that's there, because, wait a minute, I do care. This one has a minimum, but on the other side, I do want to stop on this one. I do not want to stop on this one. What? Ends on. Sorry, this is just going down. Yeah, this one doesn't include a minimum. This one is more interesting. Case 2. So here it does include the minimum and also the next maximum. So then I do want to stop immediately. But only because it has a maximum, not because it has a minimum. Same thing here. So we would not want to stop here. So the first time around, I only want to stop when I see the opposite type. Which means, in the case of the minimum, that one or that one. Doesn't matter that it's flat. Does it? No, just let's stop. Although, yeah, okay, yeah, well, you know, early stop. I don't know. Or like in this case, this case, I mean. I would want to stop in these two cases because they have a maximum or a flat maximum. Okay, how do I detect if something has a maximum or a flat maximum? Arno. So flat maximum is right max, which is a right max bit rather. The flat maximum is a right max bit, and a normal maximum, say this one, means a maximum bit. So we have to detect that it contains one of those bits. Or the left max bit, of course. So has maximum should work. Yep. I don't want to call two different functions, damn it. To split it up again. No way. How about this? A lambda, two different lambdas, so do they have the same type? Yeah, I don't think so. Could use a function pointer. Nah. But yeah, this is horrible. I want to write code something like if node has extreme opposite next extreme type, opposite of whatever. It's 2 lines instead of all of this. No, has extreme seems to exist, and it takes an extreme type, and it is part of SampleNode, but it only tests. Oh, it does exactly what I want. It calls has minimum or has maximum. Okay. So yeah, forget about this one. But I don't want to break out. I don't want to break out the for loop. I just want to stop, aka continue here. And so instead of a break, I can just do this. And then negate this. And then opposite must work with an extreme. I'm not sure if it does. Yeah, it does. Okay, so if this is true, so if this is false, then it does not have such an extreme. And then I want to start looping, doing minus node or plus node, depending on the direction. As long as there is any extreme value. So advance until we find a cubic with an extreme. Okay, with a local extreme. Or we run into another local extreme cubic. That is a cubic that is used to find the local extreme, but the extreme falls outside of the cubic. So the cubic itself might not have the local extreme. So while node is not a local extreme, and I think I can just test that with is local extreme. That is a member function of SampleNode. Okay. This is has extreme, not is local extreme. Try that again. Hello, Svitoslav. Say that correctly. It's LocalExtreme. Yep, it's there. It's part of SampleNode. Great. Yeah. So while not is LocalExtreme, we want advanced, but we also want to stop if the cubic is the cubic has an extreme. So treating node as a cubic, I want to get type. And then check if that has an extreme, but yeah, maybe more like this. I could make an has extreme and then pass nothing, which then just checks everything. So that is called an overload. If you just the same name but different arguments. So overload has extreme, and then we return true if the type contains any of the bits. I'm testing here directly as well. Might as well do it here. True then. So let's say, sorry, just get the type as an integer and then compare it with the number of bits. And then if any bit is set, then we have that. And the thing that I want to test with is therefore everything that goes into has minimum or has maximum, which is like 6 bits. Yeah, okay, so when we get here, so we found the first cubic. That either has a local extreme or is a local extreme cubic. Now I want to do a few asserts because it would be very wrong if now we found a cubic that has the same extreme as that where we came from, so the same extreme as the next extreme type. However, that is possible if it is the first one. So if node equals, if we never got here, then that would be possible. So maybe at the very least I have to assert that it does have the extreme that we are looking for. Sorry, that's nonsense. The opposite, of course. The opposite extreme. But as you can see, that's kind of trivial if this was false. So if we never went into the if, because this is true, sorry, this is false, that means that this is true. And so the whole assert test is bullshit then. So we can avoid that then by putting it here. And now, well, we do know for sure. No, we don't actually. It could still be a local extreme cubic. Okay, ignoring this one for a moment, we know that it is an extreme. So it would be sufficient to test that we did not find something that has the extreme that we came from. If you came from a minimum and then we go left or right and then we find a local extreme and that's also a minimum, that would be really weird. You can't get two minimum in a row. There must be a maximum in between. Now that's actually not true, because it could be that, let's say, so we come from a minimum, so in my ASCII art, that's my problem, a minimum, and then we go in that direction, and then we find, say, a cubic that's going up, and then we find a cubic that's going up. Yeah, so I mean it's going up and up, okay? So like this. This is the function, but instead of drawing them there, I'm drawing them here. And then maybe we find a cubic that is has a maximum, but also a minimum. That's possible. So then we would not stop here, because those don't have local extremes, but this one does have local extreme, any. But it also has the same extreme, namely the minimum. So it is okay as long as the maximum becomes first, because we go to the left. So we want to check that it does not have that extreme, or something way more complex. It has both extremes, and one of the extremes comes first. And I actually have a function for that, although I forgot the name. This one has extreme order. So has extreme order tests that the given extreme you have first that extreme and then the opposite extreme, where the direction is from the opposite extreme to the extreme, given the direction. So how can we use that? So it has extreme order. The type, so that would be just node type. And then something, and then let's just datacast the direction that I have to a horizontal direction. To use this example, if we were going to the right, so this is right. I'm mixing it up. Bedtime, cast to horizontal. So this is right, going to the right. Then I want, in this case, them to be in the order, the minimum, sorry, the arrow points to from the opposite to the real thing. Okay, this is confusing. I should have copied the comment. It's kind of a side. So this thing must be on the side, that side of the opposite extreme type. Yeah, so it's more like the opposite direction. If you go to the right, then the thing that we're looking for, nah, it must be the same direction. So I can use the same direction, and then you have to pass this at the minimum in this case. So this is just next extreme type. Yeah. So this means that the opposite direction, sorry, the opposite of the next extreme comes first in that direction. And the next extreme type, though it exists, comes after that. Also, the thing only returns true ever if it has both extremes. So this is the perfect test then. So because this only returns true when it has both of them, and this is false unless we, otherwise this would be false. Therefore this is true. Sorry, it's not. Sorry, this is false because assert demands that it is true. So we have the, we don't have this extreme, but we stopped on has extreme. Therefore it must have the opposite extreme. If this assert doesn't fire. Except when it doesn't, because we finished on that the fact that it is a local extreme cubic. So I'll probably have to treat that special as well. If what is it? I don't think it matters if it is a local extreme or not. This still must hold. Whether or not it is marked as a local extreme, it's still not allowed to have the next extreme extreme, same extreme. Except in that case. It's just not guaranteed that it does have the extreme that we are looking for. But I don't think I need to exert on that unless I think the next one must contain it. The next one should contain it. Yeah, I can just assert for that, I guess. So if the node does not have the sort for local extreme, then it must be a local extreme cubic that has its extreme outside of the cubic. On the side of direction. So we assert that we must have found the opposite extreme, or node must be a local extreme. And the next one has that extreme. Where next one then again depends on that value, which is annoying, but okay. So we must have found now a cubic with the opposite extreme. We went from a minimum to a maximum. Unless we stopped because the first thing that we encountered was marked as a local extreme. And if then this is not the case, then the next one must be, this must be true for the next one. Where next is then either previous or next, depending on the direction. Right. I'm pretty sure that if, well, you can go back to the ASCII art actually. So I assume, well, both cases, okay? So we are looking for either the thing that is marked as a local extreme or a cubic that has an extreme. In both cases we stop. And even though we departed from one of these, it's also the case that if we go to the left or to the right, that we encounter something like this, but then with the opposite extreme. So if this was a minimum, again, we have a minimum here, and I just depict it like this, with here's the vertex. But if now we go that way, then we might encounter, if this is a minimum, so we might encounter something with a maximum like this, which also looks like that. So we run into one of four cases, and in this case we would run into a node that is marked as a local extreme but does not contain the local extreme. In this case we would run into something that both has that extreme and is marked as a local extreme. And in this case we would run into something that is not a local extreme but has the local extreme. And in this case we would run into something that is marked as a local extreme and has the local extreme. In other words, if we run into something that is marked as a local extreme but does not have the local extreme and we were going right, then that's case 1. Then we ran into this one, but the extreme is outside of it. This then happens if we go to the right. If we go to the left, then of course it is this one, I guess. Yeah. Then we find B, but extreme is outside of it. And in both cases, that means that if we go one step further, so from B to C, then we have a cubic that does contain it. And here as well, if you go one further, then this cubic contains the minimum. So if the only problem there is then that in this case, C might not exist. So we might find this thing, which is marked as a local extreme. But we can't go to C to check if that is has a local extreme, because it doesn't exist. But yeah, that's another special case which you just won't test, I guess. Moreover, the only thing that I'm interested in is a star anyway. But okay, I want to assert it. So I'm going to assert that we have to go one further. I already did that, didn't I? Okay, now I'm confused. Yeah, this is where we go further. So this one might not be possible. This is always possible, because if it is a local extreme, it must have a cubic. If it has a cubic, it has a next node. How do we test this? Something or parentheses around everything. Yep. So again then, if we came from the left this direction, we will stop here. In case 2, and we came from the left, we stop here. In this case we stop at C, and I want to find the start one. And in this case we should have stopped at B as well. But we might have stopped at C here. And if we come from the other side, then we would have stopped at B. So we also also have to go one further. Yeah. At most one further. It might not even exist. It might not be marked as local extreme, But if there is a local extreme, then it is one further in the same direction. So yeah, this is a problem, really. I mean, if a local extreme is something that is marked as a local extreme, has both as two extremes, what the fuck? My code can't deal with that. I only have one local extreme pointer. So this should never happen. I'm afraid it is theoretically possible. So pretty difficult to achieve, but it is possible. In that case, I'll just have to add an ask for an extra sample, I think. Or maybe I already did that, because we do have 3. No, we don't yet. Wait a minute. Not at this point. Maybe I should delay all of this until I have 3 points that I can use to fit a 4-3 polynomial. I think that after that it's kind of impossible that this would happen. Although, no, also not. I could already have 3 points that fit the current cubic. The current cubic, yeah, closely to the extreme. And then still it fits some other point past another extreme. So it contains 2 extremes. I think that would especially happen if the underlying real function is a cubic. I mean, yeah, well, you only need a single cubic then to fit the whole thing, and then it has 2 extremes. But it is unacceptable, I think. It is unacceptable. In that case, I just have to probe something in between those 2. Maybe we should add an assert here that this is never false. Oh, that's also nonsense. Can't do that. Damn, I have a problem here. Yeah, I think I just have to disallow this. Let's okay, so we can't deal with this. Please fix so that this never happens. So now this is always true. So now I can do if this was true. Still true, that we did run into that one. This is a NeoVim one tube. With my own syntax highlighting, so the colors you won't get out of the box. Just warning. But yeah, you can customize the editor every way you want. Let's see. We're looking for a local extreme. So if this is the case, then really I just want to advance it one more time. So either it was already a local extreme and then we get here, or it wasn't and then we try to advance it one further and then maybe it is. And if that's the case, then we did find it, and now we have our neighbor. So now we can set the left or right neighbor as a function of course, again, the bloody direction. Except that we are in algorithm, and this is left neighbor as part of local extreme. So this is bullshit. We have to set the neighbor on the one that we found, which is last extreme cubic. It's the one that is being marked as, has been marked as the local extreme. So more like something like last extreme cubic, set left neighbor. CQ set right neighbor. Which then is part of SampleNode. So we just called set LocalExtreme on it, and then a little bit later we will set left neighbor. Respectively set right neighbor. And we have to do that on the LocalExtreme. So LocalExtreme set left neighbor. I think that my accessor for the LocalExtreme returns something that's const. Could change that, of course, or what did I do? Oh, it's a non-const LocalExtreme reference. Yeah, then maybe this is kind of silly. That just moved to the LocalExtreme. Not really where it belongs. Where shall I put it? Left neighbor, right neighbor. Accessors. Let's do it like that. Nope. I thought we would, no, it was in the 900 something, 960. Yep, close enough. So we have to call LocalExtreme here, which then returns a non-const reference. Yep. And then in order to know if it works, we'll print some debug output for now. Let's make this big again. Oh, I can't do that because this is LocalExtreme and we don't know who the owner is. Yeah, okay, that sucks. So then, never mind. I'll just print it from the caller. Which was algorithm. Nehor of blah 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 to the same thing. I have the feeling I will get something. Oh yeah, the minus minus might not be possible. Well, that should do it. Let's try it out. Oh, it's an enum class. It's so boring. That is a quick die. Oh, because the test suit is running. That's interesting. Interesting. So yeah, I don't know. Let's draw the thing. This comes from here, which is line 491. I1 is 2. Starting at I1 is 2. well, 4 or 5, whatever. So here in the test suite we drop the second point exactly in the maximum immediately, like bang, which then also immediately detects that this is a maximum because it's fitting the cubic through 0 and 1, which happens to be exactly the function itself. So completely overlaying it, purple thing. And then we want to jump to the maximum, which turns out to be exactly, because it's -3 I think, where 1 was. So this is the case where B is on top of, it's not a little bit left or right, but it's exactly on top of the extreme itself. And because the step is 0, it just remain where we were. We call handle local extreme, and then number 1 is actually the cubic. There's only 1 cubic. It's cubic between 0 and 1, so 0 has the cubic, and that one is then marked as a local extreme. And then we do stuff, but what exactly are we doing? Well, we have a restart, handle local extreme. I think that's good enough. So rerun. That's a funny draw. I get this back. Something went wrong. Okay, ignore the drawing. No, just the thread was stopped. Now it did run and it's being drawn again. Okay, so we are where we are now. The point where that's annoying. The point where we pass -3. We just passed -3. No, it was already detected as being, it didn't pass it. It was already detected to be a local extreme. So the last, the chain last must be this one, which must be 1 then, no? Chain last is 1. And the one that we are marking, going to mark as local extreme. It's maybe not even set yet. Let's just go next. Yeah, here, the last extreme cubic. So now last extreme cubic, the thing that is going to be marked must be 0. So I can put that here. So this is the cubic, so this must be 0. And it is. And then here I mark it as a local extreme, which means that we just create we create a heap allocated local extreme thingy, and assign that to this standard unique pointer in the sample node, and then that marks it by setting this, that marks it as a local extreme, and well with the type maximum. Obviously this is maximum. Good. Well, that was it. Now, is this a case 3, 4 or a case 1, 2? But it is, this is unequal, we know that. So it must be a case 1, 2. Can we understand that? Let's have a look at the ASCII art. Yeah, so it's either case 1 or 2, because B is exactly on top. B1 is B, which is exactly on top of the extreme itself. So there is not really a difference between the two. And the star here, that is the cubic, the marked local extreme cubic. So that is the 0. So it is indeed case 1, 2. It's definitely not this one, because, well, then the cubic, the left node of the cubic should have been in the extreme. That is just not the case. So yeah, this is false. And then we are going to attempt going to the left. There's hardly any. It is definitely not going to the right. It's not possible. Going to the left is only one thing. Not very exciting, but still it should not should. So the direction should be left. Okay, so the starting node for this case should always be that one, either 1 or 2. So the starting node should be 0. So if we do next, then node must be 0. Yep. And then we assert that that node does not have the opposite of, hopefully this is maximum, yep. So it does not have a minimum. Now, well, that's funny because, oh, wait a minute. Okay, let's print the type. I think it's just up, right? Left max. Okay, well. So it's the left part of a maximum, yeah? So this is a maximum, and then we have the right part here and the left part on this side. So this one is the left part of maximum, meaning that it ends in being completely horizontal. And that should not contain the minimum. It does not contain a minimum. So this assert should hold. And then if the direction is to the left, we're going to advance to the left. Now, nothing was marked as a local extreme yet, or was it? I think node was marked as a local extreme, actually. Oh, what? Yeah, haha. Okay, that's stupid. Yeah, okay, so we found ourselves, and that's not good. So we should be going to the left until we find a local extreme, but we should not find ourselves. So if we start at a star, then I should not start with this test. But okay, even if we don't do this, the node also has an extreme. So also should skip this. They're doing minus node on the node that is chain begin. That's what's going wrong. No. Wait, if not local extreme, so we don't do that. We don't do anything. What is the code is wrong, but not doing anything is correct. But yeah, now it looks like we found an extreme. We found an extreme of the same type, because we're still on that the same node of ourselves, and it doesn't have a minimum, so this fails. Yeah, okay, now I get it. I think I'm gonna deal with this tomorrow because it's getting late and I just should go. Let's leave it open. So, good night.